So let's start first of all. Who can tell me what is trigonometry all about? Say again. Triangles. Something about triangles. Now I want to ask you guys, since grade like 6, 7, you've been doing triangles. Why all of a sudden we get to grade 10 and we introduce trigonometry? Why is it even necessary for us to introduce trigonometry? Hello? Okay, let me rephrase the question. Why is it necessary for us to introduce trigonometry and then trigonometry becoming almost the basics of all maths you are going to do after school? Because we're going to mix it with algebra, we're going to mix it with calculus that you do next year. We are going to mix it with graphs. Okay, let me quickly explain this to you guys. And this is a very worthwhile thing to remember. Trigonometry is the study of triangles, yes, but what about triangles? The relationship between the size of the angle and the lengths of the sides. Why is it different from what we did previously? Previously, we only did the angles or only did sides when we did Pythagoras. We never mixed the two, really. Trigonometry tells us that relationship. Now, hopefully by this time of the day, you guys will know SOHCAHTOA, or whatever your teacher taught you. Okay, some old hens cackle and howl till old age. I don't know. There's so many different mnemonics about this. I love to teach my guys SOHCAHTOA. That if I'm looking from theta with opposite, adjacent, and hypotenuse, that sine of theta is equal to opposite over hypotenuse. Cos of theta is adjacent over hypotenuse. And tan of theta is equal to opposite over adjacent. Okay, you guys know this, hopefully, well at the moment. But now I want to challenge you guys. What about the reciprocals? Sec, cosec, cot. What about those three? Now some of you might go and say, but sir, in grade 10, my teacher did it like in one period. And then they just moved on. Yes, because it's not examinable in grade 11 and 12. But here's the secret. And it's not a secret you want to know. In varsity, get to first year, sec, cosec, cot is just part of the curriculum. They assume you can do it the same as you can handle sine, cosine, and tangent. So please don't forget about them. And then get the fright of your life when you walk into calculus and they go sec, cosec, cot, and you've just got to be able to do them. So let's quickly recap. Is there any one of you that know the reciprocals and which one goes with which one? Yes. What do you say? Sec goes with? With cos. Okay, and cot goes with? How do you remember that? Went to sit on my backside and I studied that, sir. Right? Let me give you a nice little trick. Look at the third letter of the reciprocal. Sec, the third letter is C. So it goes with cos. What about cosec? Third letter goes with S, so it's 1 over sine. Cot, 1 over tan. For those of you that are doing AP Maths, this is part of your curriculum. Sec, cosec, and cot must be part of your curriculum. So this means that cosec is h over o, sec is h over a, and cot is a over o. Okay? Easy, simple, and straightforward. Everyone all right with this? Okay. So you've got to know these and work with them the same with sine, cos, and tan. Please, very important. Okay. Now I'm going to go very quickly onwards towards reduction formulae. Okay. Reduction formulae. What does the word reduction formula mean? Reducing an angle, right? So it means reduce. Why would we want to reduce? Yes, what do you say? Okay, can't exceed 180 degrees. Yes, but let me take it one step further. You would like all angles that you work with be between 0 and 90 degrees. Why is that? Who can quickly tell me? Because according to the cast diagram, between 0 and 90, all angles are positive. All ratios are positive. So for instance, if I want to compare sine of 150 and sine of 330, it's really difficult. It really is really difficult because 150 and 330 has got nothing to do with each other. But if I could get them in between 0 and 90, the angles, then I can say, oh, here is a relationship between them. So I'm going to tell you guys two things, and if you can learn to do these two things, in all simplification of trig, you are going to score big time. Step one, in all trigonometry, no matter what trigonometry we do, you want to work with angles between 0 and 360. So if your angle falls out of 0 to 360, you get it between 0 and 360. That's always step one. Step two, get your angles between 0 and 90. That's your step two. And then we are going to compare. Now here's the wonderful thing, sir. If you can learn to do that, I promise you, in all simplification, you are going to score at least 60 to 70% of marks, even if you couldn't finish the sum. Just to get the angles between 0 and 90. Then after that, we can do some funky kind of magic, okay? But that's going to be our two steps. But let's quickly recap the cast diagram. Here you've got cos being positive, sine being positive, tan. So I've got C, A, S, T, the cast diagram. What I have found in the past, in all my years of teaching, is that when you guys mess up with a cast diagram, you will struggle to finish off the sums. Because you forget to make one of them a negative where it should be a negative. Or you make it a negative where it should be a positive. But then sometimes the things just don't work out the way we wanted, we intended, and you get stuck halfway. So I'm going to tell you this. If you are struggling with trigonometry, your first steps are make sure your cast diagram is always 100%. Always, always, always. Okay. Let me stop ranting and raving here. Okay, so I'm going to just go and make it simple. C-A-S-T. In the first quadrant, we are going to work with theta. Okay, we're just going to always assume in simplification that all thetas lie between 0 and 90 to avoid confusion. The second quadrant, we're working with what? 180 minus theta. In the third quadrant, I'm working with 180 plus. In the fourth quadrant, I'm working with 360 minus. Okay? Which means, if I, for instance, have tan of 180 degrees minus theta, the job of the 180 minus is only one thing, to tell me the quadrant where it lies. Remember that. That's the only reason why it's there. Okay? So the 180 minus tells me which quadrant. Okay, there's 2, 3, 4. So that tells me second quadrant. Tan, is it positive or negative there? So it's going to be negative tan of theta. Okay? So what if I've got sine of 180 plus theta? Okay, so the 180 plus tells me third quadrant. Sine is there, negative sine theta. Okay? Now I know at this moment of time some of you are going, I know, sir. But I just quickly want to share this with you guys. And please, I'm going to talk now very specifically to the ladies. You guys have to realize that I love to talk to the ladies because I have found the reason why a lot of you don't finish your exams because you write too much. Yes, sir, but if I write more, they're going to give me more marks. No, they're not. Sometimes yes, but mostly no. In trigonometry, what I would like you to do, instead of rewriting these things over and over and over again, is just write on the top. 150 is in which quadrant? Second. In the second quadrant, I work with 180 minus. 180 minus what gives me 150? Look at the way I do it. I don't rewrite sine 180 minus 30. I just at the top of the 150, I put 180 minus theta, or 180 minus 30. In which quadrant is this? Second quadrant. Is sine positive or negative there? Sine of 30. Why do I do this? Can I tell you why? Because that's where we give marks. I don't give you marks for rewriting sine 180 minus 30. I only give you a mark for telling me it's positive sine 30. So because the problem is, you guys know those long sums. Then you guys go and write them out once for doing all the 180 pluses and 360 minuses. Then you've got to write it over again to do the pluses. Now I'm saying that's too much effort. If you don't get marks for it, why must I write it down? And believe me, your teacher doesn't look for it. They only look for this. So just write it at the top or at the bottom, like the 330. Fourth quadrant, hopefully you know that. So this gives me 360 minus 360 minus 30 gives me 330. Okay. Now, sine in this Sine in the fourth quadrant, negative sine 30. Now here's a very important thing, ladies and gents. I asked you guys, how difficult was it to compare sine 150 and sine 330? It's close to impossible. But actually, they are exactly the same, except one is just a negative and one is a positive. And that's why we want things between 0 and 90. So that we can compare how big they are. Easily. Okay? Everyone's all right with this? Okay. Now, ladies and gents, the next 5 or 10 minutes is going to save you a lot of headaches if you learn to do this correctly. I'm going to teach you guys 3 techniques that I can almost guarantee your teacher didn't teach you. 3 techniques. Now, these 3 techniques, please, is not better than your teacher. It's not that, oh, I am so smart and you've got to do what I do. No. If you don't like these techniques, don't use them. If you've been struggling with trigonometry and you struggle with negative angles and these kind of things, and you struggle with co-functions, use these techniques. I'm going to quickly have a look, first of all. Remember what I said earlier, what is our first step in trigonometry? Get all your angles between 0 and 360. But what if it's outside of that? Okay? Let's say, for instance, I give you sine of 450. Okay? What do I do? So what do you say? Why can you subtract 360? You don't know, your teacher told you, right? Okay, ladies and gents, say again. Yes. It's a full revolution. Can I quickly ask you something? If I take a straight line and I add 360 to it, is it the straight line still going to be the same? Now I'm saying 360. So I go 2x plus 360. Is it still the same or not? No, it's not really the same thing. Be careful of the thinking that simply because it's a revolution, I can add 360. Let me share this with you. What is the period of the sine graph? That's why. It repeats itself every 360 degrees. That's why I can do that. And that's why I can only do it with trigonometry. Because a parabola doesn't repeat every 360 degrees. It doesn't. This thing goes like that and it continues forever. But sine and cosine repeats. Same with tan. Now you might ask me, but sir, if you say with tan the period is 180. Yes, I know. But I don't want to make one special rule for tan and one special rule for sine and cos. So we make a generic rule that we subtract or add 360s. Because it would just mean that tan has repeated itself twice. And that's fine. It's still a repetition. So I'm going to subtract 360. And again, you just show it for me like that. You don't rewrite it. It just becomes sine of 90. Okay? Now let's quickly have a look. I want to share this with you guys. I gave this to my matrics 3 years ago. Cos of 180 degrees minus x was really funny. Was really funny because about half of my grade 12s went, so there was a typo in the test. That should have been 180 minus. And I just put a red pen through and say, no, it wasn't a typo. I meant it to be 1080 minus x. But 1080 is way too large. So what am I going to do? Subtract 360. And subtract 360 again. To get me to cos 360 minus x. Now this I can handle because it's simply between 0 and 90. Okay? Now let's quickly have a look, but what about if it is, so this would be positive cos x. I quickly want to ask you guys this thing. What if I've got cos of negative x? Okay? It's simply cos x. Oh. What if I've got sine of negative x? Now I've got negative sine x. Okay, now, how do you know this? Okay, now let me ask you this. What about cosec? Okay, now we're starting. The problem is, the knowledge you guys have is very limited to sine, cos, and tan because you guys learn this instead of understanding what it goes on. A negative x simply means I changed the direction of measurement. Instead of measuring in a positive direction, we measure in a negative direction. So what am I saying to you? You can handle a negative angle as if it's in the fourth quadrant. Because then I can ask you cosec of negative theta. And I go, cosec relates to s, sine. But in a negative, in the fourth quadrant, would sine be positive or negative? Negative. Okay? Now for those of you that don't want to work this way with negatives, I'm going to show you another trick. Just add 360s until the angle is positive. So if you get, for instance, tan of negative 510, what you can do is use this knowledge of tan in the fourth quadrant or add 360 and add 360 again. And the angle you get is tan of 210. Oh, so but that's so much simpler. It really is. Now I want to share something with you guys because you must look out for this one. Tan of x minus 180. How many of you have seen that one in the exams? What did your teacher tell you how to handle this? Say again? Okay, so you take out a negative 1 common, right? Swap it around. Then you go and see, okay, tan of a negative is a negative, right? And then half of you guys mess it up royally, right? Let me share with you a trick. Why don't you just add 360? Because if I add 360, I'm sitting with x plus 180 degrees, which is third quadrant. Oh, so but that's so much simpler. And you may use it. Understand, you may use it. You can also use a technique of taking out a negative and those kind of things. I have found this to be so much simpler. Okay, so understand, before we get to reduction, we first make sure your angle is between 0 and 360. Then we go to reduction formulas. Now the next two techniques will blow your mind. Guaranteed. Let's have a look at cofunctions. You guys like cofunctions, right? Okay. Whoops, this thing's moving. I'm feeling like I'm ice skating here. Cofunctions. What are the two cofunctions that you are aware of? Sine of 90 minus x. So if I've got sine of 90 minus x, the answer is, how do you guys know this? Okay. Can I tell you how you know it? Because you learn it. Your teacher told you that's the way it is, right? Yes. I know, I got taught that way as well. About 1.5 years, 2 years ago, I had an epiphany. Okay, I had this major breakthrough. The major breakthrough was as follows. Take sine and put a co in front of it. What do you get? Cosine. The cofunction of sine. Take cosine and take the co away. What do you get? Sine. They are cofunctions of each other. Now, what does cofunctions mean? What do you guys there in the back say? What does cofunctions mean? On this side? Say again, sir? Be careful, no, it's unfortunately not opposite. What does the word co stand for? Come on. Coexisting. Okay, so we're going to look through the alphabet, or through the dictionary quickly. Let's get all the words that start with co. Corresponding. I've got corresponding, coexisting, cooperating. Okay, guys? Hello? It means complementary, meaning angles that add up to 90 degrees. If I add these two, what do I get? 90 degrees. That's why they are co-functions. They are complementary functions of each other. You guys are with me? Okay? So if I look at cos of 30, which angle, if I take cos of 30, adds up to 90? 60. So therefore take the co away and I'm left with sine of 60 degrees. Now let me quickly blow your mind. In 20 seconds, I'm going to take you past your school curriculum so you can do cofunctions with any trig function. But sir, cosec 10 is what of 80? Take the co away, what am I left with? Sec. Tan of 90 minus x. Put a co in front of the tan and what am I left with? Put a co in front of the tan. Cot of x. And that's how cofunctions work with each other. You either put a co in or you take a co out, and that's how you get your complementary functions. Now I'm going to ask you guys, is it now necessary to go and sit really and study all of these things? No, it's just about understanding where they come from. So let me quickly blow your mind. What are the three basic functions in maths or in trigonometry? Sine, sec, and tan. Because cos is co-function of sine. Cosec is co-function of sec. Cot is co-function of tan. So your three originals are sine, sec, and tan. Okay? Just randomly. Now let's quickly have a look at making life easy for you. In the first quadrant, I'm going to work with 90 minus. In the second quadrant, I'm going to work with 90 degrees plus. And in the fourth quadrant, I'm going to make life easy for you. We are going to work with theta minus 90. Okay, theta minus 90. Okay? I just quickly want to say one thing. For those of you ladies that maybe that are sitting here that's feeling a bit behind the camera, you are more than welcome to either move to the front or come and sit this side. Won't hold it against you. Okay? So make it easier for you to see. Why do I ask you to label it this way? Because now I can give you any co-function. So for instance, I give you cos of 90 degrees plus x. First of all, the 90 tells me I'm going to work with co-functions. So what is the co-function of cos? Sine of x. But now, be careful. The 90 plus is in which quadrant? Second. Is cos positive or negative there? Cos. So it's going to be negative sine x. Now I can do the same thing with the fourth quadrant. X minus 90. With the x minus 90. Again, I see a 90 degrees, which tells me I'm going to work with the co-functions. So it's going to definitely be sine of x. But now, x minus 90 is which quadrant? Look here. Fourth quadrant. Is cos positive or negative there? So it's positive sine x. So here's my tip for you, sir. When you get your paper 2, you take 5 seconds or 15 seconds and draw this diagram up for yourself. And you've got your whole cheat sheet for the whole trigonometry part. Okay? Take 15 seconds, half a minute. Write this cast diagram with the 90s, the 180s, all of that, write it in there. Now, ladies and gents, this is the second technique that I would love to have taught you guys today. The last one, and this is a very important one, is you've got to know special angles. You have to know special angles. How many of you are passionately, deeply in love with your calculators? Oh, yes. Even when that teacher in the trig exam tells you, no calculator, I sneak it in, I go, sine of 30. Right? Let me quickly just make something very abundantly clear. When you go and apply for university, and you go and write your NBT exams, no calculators allowed. And they love trig without a calculator. So you have to forget about that love of your life for a while and get used to working with special triangles. Now here I can say, there are 5 different ways of doing special triangles. You've got to find your own way. I've got a way that works for me and my students. I'm going to show that to you guys because it takes me 10 seconds to draw up all the special angles I need. And I can do that as long as I can count to 4. Okay, and hopefully all of you can count to 4. Now some of you are going, sir, I hope that's not an insult. Maybe a little bit. No, I'm joking. Okay. So, sir, could you can count to 4 for me, right? Okay, hopefully. Count for me from 4 backwards. Okay, wait. 4, 3, 2, 1, 0. Okay, would you repeat that for me, please? There you've got all the special angles you need. Now, before any of you math whizzes freak out and go, but sir, you cannot have a 0-degree triangle. I know. But sir, you can't have 2 90 degrees in a triangle. I know. I simply draw this up like this so that I can do any angle between 0 to 90. Yes, this one and this one isn't real triangles, but it helps me to be able to go, okay, cos of 0 degrees adjacent over hypotenuse 1. It helps me to go tan of 60 degrees opposite over adjacent. It's a quick, easy, if you can do 5 seconds or 10 seconds, you can draw up all the triangles you need. Okay, all of you guys with me? Go. Yes, sir. Yes. Now I want to quickly, sir, what is your name? Say again? Oh, okay, I'll get it during the break because I'm struggling to hear a bit there. Ladies and gents, I want to quickly just say one thing. For some of you, you might see, even those guys at home, that the 45-degree triangle, some of you have learned 1 root 2. It's the same triangle, man. All that they did is they divided each of these by root 2. And you get the same triangle. It's a ratio. Okay? So I encourage you guys to find a way that works for you. If you do that table, if you do that quadrant with a circle, or, well, I don't know, whatever your teacher taught you. Or if you struggle, use this. I teach this to my grade 10s and 11s, and I found that they get it right. Because there's no confusion, there's no where does what go. There's simple count from 4 backwards, and all your hypotenuses are 2. Simple and easy and straightforward. Now, I know some of you have almost like been dozing off for a little bit because, so this is so much theory. I'm feeling like I'm drinking out of a fire hydrant. We are almost done with the theory, guys. We are almost done. Okay? The last bit of theory I would like to quickly go over before we go and practice this is just your 2 special identities. Your 2 special identities. Your 2 special identities. The first one was that tan of theta is equal to sine of theta over cos of theta. Can someone quickly tell me, when do I use this? When do I use this one? Okay, well, let me ask you, let me rephrase the question. When do I not use this one? Is that better or is it worse? It's worse. So, we get a bit high. Okay, I just want to say that my kids get a bit hyperactive. The first time that they learn about tan theta being sine theta over cos theta, we use it everywhere. I don't care, so if I see a tan, I use it. Okay? Yes. Okay. So let's quickly, in what type of a sum are you working with? Okay, so we use it but when we're proving identities, right? Definitely. We use it when we prove identities. Prove that tan of theta times wada equals to ta-da. Yes, we use it. Where else do we use it? We use it when we are simplifying sums where there are no values for the angles. Okay? When do I not use it? When I'm solving equations. Mostly. There are times when you're going to use it, but mostly. Okay? Then lastly, I don't use it, okay, when I've got special angles. Because at special angles, I just use tan of whatever angle is given to me.